Hi everyone, this is section 3.3 on more properties of logs, and a lot of people get confused by these, but they're beautiful and awesome once you master them. Now, first of all, let's learn how to read log expressions, because in my notes and in old books, it can be kind of ambiguous what something really means. So, for example, uh, remember that if you want to talk about ln of x, right, I strongly recommend that you put parentheses around the argument. Okay, in my old notes, I was kind of sloppy about that, and many books are sloppy with that. So if you're kind of confused what an expression really means, let's look at some conventions. And you see this on the homework as well. So we will use grouping symbols ideally as a means of clarifying the order of operations in expressions. Often grouping symbols are omitted when they could have helped. How do we read log expressions in these cases? Now here, I'm going to use ln, the natural log, for convenience, but these are issues with various log functions, common log, log base 4, whatever. All right, so for example, if you see something like this in a book, all right, ln 3x plus 7. Normally, the ln is considered to apply to products, powers, and quotients that follow it. So over here, it's assumed that the argument is 3x. We're taking the natural log of 3x. If you want to do overkill, you could put all this in brackets, okay? And then the 7 is added to the whole thing over here. But if you see ln 3x plus 7, the ln is assumed to apply to the 3x. 3x is the assumed argument, and the plus 7 is loose. It's out there. If you actually want ln of the quantity 3x plus 7, put parentheses around the whole thing in here, 3x plus 7. Okay, ln 3x to the fourth. Again, for products, quotients, and powers, we assume that the ln applies to this mix over here, and all of this is the argument. Bear in mind, if you use Wolfram alpha, sometimes there's some ambiguity even for something like this, ln of x to the fourth. ln of x to the fourth. Okay? Now, normally the way the books would interpret this, most books would interpret this as ln of the argument x to the fourth. But Wolfram alpha has this legitimate idea that functions bind more tightly than exponents. So Wolfram alpha is more inclined to say that this is ln of x all to the fourth, which is really stressing as to why it is that you really should put parentheses around your arguments so there's absolutely no confusion, and put parentheses around complicated bases as well. Basically, use grouping symbols. They can help a lot. All right, ln x to the fourth, as I just said, most books would interpret that as x to the fourth being the argument, but Wolfram alpha may interpret it like that. But these are not the same thing. These are not equivalent. So it's important that you know how to read this. So as a student, you should write this as either this or this to be super, super clear. In fact, you might even want to do overkill and put the parens around the x. All right. Again, generally speaking, if these guys are followed by a product, quotient, or power, or a mixture of those, then the log is assumed to apply to the whole expression that follows. If you have plus or minus signs, they tend to break things off, unless things are in grouping symbols. All right, so enough for reading. Log properties based on laws of exponents. All right, so remember that logs are exponents, and the laws of exponents directly translate to laws for logarithms. Okay, now remember, we only take logs of positive values, okay? So we're going to assume here that a and b are positive, where a and b represent maybe constants or variable expressions. Back here, we're going to state these properties using natural log, ln, but again, these apply to any log function with a nice base. And we have to be consistent. If we're talking about log base 4, for example, I'm assuming we're talking about a bunch of log base 4s. We don't want to mix log base 4 and log base 5, say, just yet. We'll need the change of base property later on. Okay, in one direction, from left to right, we're said to be expanding the expression. From right to left, we're going to be condensing the expression. Okay, so what's an example of a log property? Well, let's go back to a basic law of exponents. X to the second times x to the third. How do you simplify that? Well, this is going to be x to the fifth. Why? You did that automatically. What did you do? Well, when you multiply powers of x, you add the exponents. 2 plus 3 is 5. So the exponent on a product is the sum of the exponents. All right? Exponents are logs, right? So what are we saying here? What are we saying here? I'm going to move this down. Well, okay, let's not then. All right. The product rule. ln of AB equals ln of A plus ln of B. The logarithm on a product equals the sum of the logarithms. All right, so I'm going to rewrite what I wrote above. X to the second times x to the third is x to the fifth. All right, so in order to find the logarithm, the exponent for a product, what do? You take the sum of the exponents of these guys over here. The exponent or logarithm on a product is obtained by the sum of the exponents. The log of a product is the sum of the logs. The log of a product equals the sum of the logs. Here I use powers of e. Okay, likewise, we have a quotient rule. All right, so remember, x to the fifth divided by x to the third is going to be x to the second, right? What did you do? When you divide powers of x, you subtract the exponents. The logarithm on a quotient, the 2 here, is obtained by subtracting the exponents or logs over here. All right? 2 is 5 minus 3. The log of a quotient equals the difference of the logs. When you divide powers of x, you subtract the exponents. That's the idea. Here's a related idea with powers of e. Okay, so if you agree with these basic rules for products and quotients for exponents, then you should agree with these rules for products and quotients involving logarithms. All right, by the way, don't confuse this with ln of A over ln of B. That's different. That's the change of base property. A lot of students confuse those. Again, grouping symbols, critical. Now for our next property and our next rule, the power rule. All right, so let's say we have x to the second all raised to the third. That's x to the what? It's x to the sixth, x to the sixth. Because when you raise a power to a power or exponent, you multiply the exponents. The power rule. All right, so when you take a log of a power, okay, a to the p, I should put grouping symbols here, you can smack down the p. That's like WWE SmackDown. You can smack down the p. The basic idea is that in our example here, x to the second itself was a power, right? And we're raising a power to an exponent. So we have this power guy being raised to an exponent. Okay, the exponent comes down. ln of A was the exponent. It was the 2 up here, right? Basically. So 6 is 2 times 3. Okay, 6 is 2 times the 3. Okay, that's basically being smacked down. That's the idea. All right, the smackdown rule. So again, from left to right, it's expansion. From right to left, it's condensation. Okay, from left to right here, that's the smackdown rule. We can smack down the p. That's expansion because this is kind of an expanded, longer expression, bigger expression. I call the reverse the basketball rule, going from right to left. You can throw up the p like a basketball and get that. That's condensation. This is a shorter, more compact expression. Going backwards, the product rule, going from here to here, that's expansion. You're making it longer. Going from here to here, that's condensation. You're making it more compact. For the quotient rule, going from here to here, that's expansion. You're making it longer. From here back to here, that's a condensation. You're making it more compact. All right. Now, this is key. Just like we don't have a rule for the square root of a plus b, remember, we do not have a rule for something like this, right? You may just leave it b. Likewise, we don't have a rule for the log of a sum or a difference. So basically, don't break this thing up. As it stands, you cannot break this thing up. All right. So if you see something like ln of a plus b, you typically leave it. Okay. I would like to go back to the power rule because, well, as they said in Spider-Man, with great power comes great responsibility. Okay. Now, before we get to the power rule, one quick idea here. If you forget the rules, you might be able to use powers of e. So for example, to test out the product rule, you can plug in a equals e to the second, b equals e to the third, work it all out, and you'll get 5 equals 5. See, if you had made the incorrect assumption that the log of a product equaled the product of the logs, then you would have gotten 5 equals 6, and you knew that you were on the wrong track. By the way, that's a good way of looking at these rules before we get to this abuse of power that I'm going to talk about. Going back to the product rule, I often think of it this way. The log of a product is not the product of the logs. It's not ln of a times ln of b. It's the sum of the logs. You're going one step down in the order of operations. The quotient rule. The log of a quotient is not the quotient of logs, ln of a over ln of b. Instead, it's the difference of logs. The log of a quotient equals the difference of the logs. Okay. Power rule, once again, is the smackdown rule. Okay. You can smack this guy down. Now, the power rule, again, we're in danger of abusing, and with great power comes great responsibility. The Spider-Man quote. Okay, so how not to abuse power? Let's not be a politician. How not to abuse power. But like a politician, I'm going to cover up. All right, more on the power rule. So basically, what can you do and what can't you do? What can you do and what can't you do? That's an important theme for this class. All right, so once again, the power rule for logs is the most commonly abused rule of these three. All right, so in the following examples, yes or no, are the two expressions equivalent, assuming x and y are positive, or are they not equivalent? Could we find counterexamples? Over here, ln of xy to the third. First of all, let's read it. ln of the argument xy to the third. All right. Now, can we smack down the 3? Can the 3 come down? The answer is no, because the x is in the way. You have to ask yourself, what is the base for the exponent? Is it xy? No. The base is only the y here. So no. If a student tries to smack down the 3, that's wrong. These are not equivalent. The 3 does not apply to the x. It only applies to the y. So in fact, you'd use the product rule first. You'd want to break this up using the product rule. The log of a product equals the sum of the logs. We'll talk about that later. Okay, our next victim here. ln of the cube of xy. We're assuming the ln applies to the whole power here. Can we smack down the 3 in this case? And the answer here is yes. The 3 can come down 3 times ln of xy. By the way, I just realized it might be a good idea to even put brackets around this guy over here. The 3 can come down 3 times ln of xy. We would have equivalence here, and I would put parentheses around the xy, because the 3 applies to the entire base here, xy. All right, so the 3 can come down, xy, the argument here, okay, was the base over here, so that works out. Again, I'm assuming x and y are positive in value. Next, the cube of ln of x. Here, grouping symbols aren't so necessary. This is fairly clear. The cube of ln of x. Can we smack down that 3. Can we do this? And the answer is no, we cannot do that. Because if the natural log is part of the base, we simply cannot do that. There's no rule for that. Okay? Because since the 3 applies to the ln as well, we're not allowed to smack down. So when are we allowed to smack down? Okay. In this case here, ln of x cubed, I'll go ahead and mark it up here. Ln of x cubed. Okay, here, 3 only applies to x, not to ln, so the 3 does in fact smack down. Ln of x cubed is 3 ln of x. These are equivalent. So, the power rule, don't abuse it. Know when you can use it, and know when you cannot. Over here, the 3 does not apply to the x. We cannot smack down the 3. Over here, the 3 applies to the xy. Again, it might be a good idea to put brackets around this to make that clearer, that we have ln of all this. The 3 we can smack down. Over here, the 3 applies to this whole log guy. We're not allowed to smack down the 3. Here, the 3 only applies to the x. We can smack him down. All right. So do not abuse power. One side note, and this will bite you once in a blue moon. Let's say we have ln of a squared. All right. But what if we allow a to be negative in value? All right. Well, then when we smack down, technically we're supposed to put absolute value. So if you're smacking down an even exponent like a 4 or a 6 or an 8, and a could be negative, then you should put absolute value. That's kind of similar to the idea that the square root of x squared, remember, was not in general just x. It was the absolute value of x. And this is a similar idea. It may bite you once in a while. Okay, so now let's apply these rules in actual expressions. All right, homework problems. Expanding log expressions. So first of all, let's expand this over here. I'll blow this up a bit. Let's expand ln of the cube of ex. Sorry, the cube root of ex. Okay, now first of all, notice that we're taking the natural log of all of this, and overall, we're taking the log of a power. How can you rewrite this as a power? This is ex to what exponent? This is ex to what exponent? When you take a cube root, you're raising something to the 1/3 exponent. Okay, here it is much nicer. Again, you may want to put brackets to be super clear. All right, so ln of the cube root of ex, okay, that's ln of ex, that's to the 1/3. Now, what can we do with the 1/3? Yes, we can smack it down. 1/3 ln of ex. And remember, I'm assuming here that all variables are restricted to positive values. Okay, so the 1/3 smacks down. We now have this. But we're not done, because I can expand that. The product rule. The log of a product equals not the product of logs. It's the sum of logs. So 1/3 times, and a lot of people forget these grouping symbols. You really need these, because the 1/3 applies to all of this. Common error, by the way, to forget these. It's 1/3 times all of this. The sum. The log of a product is the sum of the logs, ln of e plus ln of x. The parentheses aren't so necessary over here for the e or the x. But wait a minute. You must evaluate ln of e. You can simplify that. What is ln of e? It's 1. You better remember that. So when you're expanding this over here, we get this. Now, some people might say, well, shouldn't we distribute the 1/3? You could, but I wouldn't require that. If you write this, I'll call that expanded, although you could distribute and get this over here. All right. So we've expanded. We've turned this compact expression and made it longer. So why would we want to do this? In calculus, if you're asked to take the derivative of this, you'd much rather rewrite this as this, and derivatives are much easier to take when you have something of this form. Derivatives tend not to like powers or roots as much. So log properties are your friend. Calculus would rather have you write this as this. It's easier to take derivatives and also integrals. Okay, Next example. Let's expand log base 2 of the fraction, this quotient, 8x cubed over y. We're taking the log of a quotient. Now, the log of a quotient is not the quotient of logs, it's the difference of logs. And remember, it's log base 2. Be consistent. All right, so log base 2 of this equals log base 2 of the top, 8x cubed, minus log base 2 of the bottom, y. Now, actually, you can skip this step if you go all the way and apply the product rule over here. Basically, you can skip maybe a step or two as you do these problems, because there is a pattern that we'll see. In fact, for some problems, I might accept answer only, because by the time you take calculus, you get so good at ripping this apart and evaluating little pieces. But for now, let's do it step by step. Okay, here we're taking the log of a product. The log of a product is not the product of logs, but the sum of logs. Log base 2 of 8 plus log base 2 of x cubed, and then minus log base 2 of y. Don't forget the little 2's here. It's a mistake to forget or omit those little 2's. You must put them all in. Now, many students will be able to go straight from here to here directly, right? Factors of the numerator, they're going to correspond to plus signs in front. Factors of the denominator, they're going to correspond to minus signs in front. So with time, you'll be able to go from here to here pretty quickly. But there's still more to do. Over here, what is log base 2 of 8? 2 to the what is 8? 2 to the what is 8? Well, 2 to the third is 8. Also, what can we do with this 3? Well, the 3 is on the x. We can smack the 3 down by the power rule. So we get 3 plus 3 log base 2, don't forget that, of x minus log base 2 of y. And that's that. Don't try to tear these apart. Okay. Next. This, I would accept answer only. It helps that we assume it's a common log. We don't have to keep writing 10. But it turns out that we can write this in one step in calculus. All right, so what's the bottom line? Factors of the numerator are going to have plus signs in front, unless maybe you have negative exponents. Factors of the denominator are going to have minus signs in front. All right. Step by step, the log of a quotient, right, is not the quotient of logs, it's the difference of logs. Okay, so basically, I could have started like this. The log, maybe I should have put this step at first. Log of a squared b cubed, all right, minus, I'm applying the quotient rule, log of c to the fourth d. Okay, so if you want to apply the quotient rule directly, you get that. Log of the top minus log of the bottom. But here, we're taking the log of a product. Here, whoops, here, log of a product. We use the product rule. The log of a product is the sum of logs. The log of a product is the sum of logs. And once again, we need these grouping symbols, those parentheses. So then, when we expand this thing out, all these exponents then smack down. All right, we get, and again, many students can go from here to here. We get 2 log of a plus 3 log of b minus 4 log of c minus log of d. Now, I must stress this. This is by far the most common error that students make on an exam. They don't know that's a minus sign because they fail to group over here. Remember what I said earlier. Factors of the denominator ultimately are going to lead to minus signs in front, okay? Unless you have like a negative exponent on here, all right? So it's minus log of d. The d here is a factor of the bottom. One way to see that, be careful with grouping symbols up here. But again, in calculus, you should be able to go from here to here in one step. 2 log of a plus 3 log of b minus 4 log of c minus log of d. All right. Now, why would we want to tear this thing up like that? Well, like I said in calculus, instead of taking the derivative of that, we may rather take the derivative of that. Okay. Now, how about a condensation problem? Let's do a couple of these. All right. So let's condense ln of x plus 3 ln of y. All right. Now, this 3 is really in the way, right? He's in our way. So what can we do with this? Well, basketball, the power rule in reverse. All right. The 3 goes up here. So then we have ln of x plus ln of y to the third. Again, let's assume that x and y are positive in value. Now what do we have? I'll put parens here. The sum of logs. The sum of logs was the log of the what? It wasn't the log of the sum. It was the log of the product. So we have ln of xy cubed, and that's that. Actually, we talked about him before. He was way up here, remember? Okay, ln of xy cubed. We talked about him way up here. Okay. All right. Let's condense this. All right. So 1/2 log of 3x plus log of y minus 3 log of z. Once again, these coefficients sort of are in the way. So what do? We're going to play basketball. Move up the 1/2, move up the 3. And I'd recommend moving up a 3, not a -3, because then that'll be confusing. All right. So we bring up the 1/2 over here. And remember, we need grouping symbols because the 1/2 applies to all of 3x. For good measure, I'll put brackets here. And parens over here. Okay, so log of the 1/2 power of 3x, which is the square root of 3x, plus log of y minus log of z to the third, the power rule. We're condensing. All right, bottom line. The sum of logs is not the log of the sum, it's the log of a product. And then the difference of logs is not the log of a difference, it's a log of a quotient. Again, sum of logs, log of a product, difference of logs, log of a quotient. But with time, you should be able to go maybe from here all the way to here even, okay? Or at least from here to here. All right, so log of, I'll put the y in front, because remember, you're not supposed to extend that radical too far. Y times the square root of 3x all over z cubed. Now, why would we want to do this? Well, this comes up if we're solving equations. Let's say we want to set this equal to 0 and solve that equation. It turns out to be better to condense this like so and figure out where this thing is equal to 0. Okay, so that's all for now. In the next lesson, I'll discuss the final part here, the change of base formula. But we'll wait till next time.